So in this lecture, we'll be looking at the notebook to do text classification using a CNN. We'll begin by downloading our dataset, which will be the BBC News data once again. But note that at this point in the course, you've learned the skills to plug in any dataset you like. So please feel free to do that as an exercise. The next step is to import everything we need for this notebook. The next step is to load in our CSV using pd.readcsv. The next step is to call df.head to remind ourselves what our data frame looks like. As you can see, we have two columns, text and labels. The next step is to assign numerical targets for each of our labels. The next step is to determine the number of classes, which we'll call k. The next step is to split our data into train and test. The next step is to convert our text sentences into sequences. Note that we are now not using TF-IDF, but instead we'll be representing each document as a list of integers. Note that we've set the max vocab size to 2000. The next step is to assign our word-to-index mapping to a variable, and also to check the true vocab size. As you can see, there are over 27,000 tokens. The next step is to pad our training sequences. As you can see, our documents are quite long, with a maximum of about a few thousand tokens. This makes sense, since they are news articles. The next step is to pad the test sequences as well, but this time setting the max length to t. This will emulate how we use this model in the real world, since we wouldn't know the length of any future data that we want to use this model on. The next step is to create our model. You can see that I've chosen an embedding size of 50, but you should feel free to change this as an exercise. The next step is to create our CNN layers. So we have the input, followed by embedding, followed by conv1d, followed by global max pooling, followed by dense. Note that I've commented out the extra convolution and pooling layers, but as always, you should feel free to test different combinations as an exercise. Remember that there is no formula for hyperparameters. You simply choose them based on experiments. The next step is to call compile and fit, all of which you've seen before. The next step is to plot the loss per epoch. So the loss per epoch looks good. The next step is to plot the accuracy per epoch. So the accuracy per epoch looks good. As expected, performance on the train set is better. So as a final exercise for this lecture, please continue computing other metrics, like the F1 and the AUC. In addition, compare the performance of this model to previous models we used on this dataset. You may be surprised at the result. Consider why this is the case and think about how this might help guide your decisions about which models to use in the real world. Finally, you'll notice that something I mentioned about hyperparameters earlier has now come to fruition. In particular, as our models become more complex, we have many more hyperparameters to choose. You can choose the filter size, number of feature maps, number of convolution layers, whether to use flatten or global max pooling, and so forth. This is in addition to the ANN part and simple things we saw before, like learning rate.